We have problem 33 gave you a lot of problems on the homework, so I thought I'd go over it and do a little video, especially since it's relative motion. So we're told that a canoe has a velocity that's southeast, and this is the velocity relative to the Earth, and it's 0.48 meters per second. And we have the river flowing east, and it's 0.48 meters per second, and this is the velocity of the river with respect to the Earth. This is the velocity of the canoe with respect to the Earth. And we want to know the velocity of the canoe with respect to the river. Actually, we want to know the magnitude. So the idea being here is that this is the motion of the canoe in the moving frame of reference. Like, the river is my moving frame of reference. And so this is the speed of the canoe in the river. If I combine the velocity of the canoe with respect to the river plus the velocity of the river with respect to the Earth, the sum of these two would give me the velocity of the canoe with respect to the Earth. I like to think of these subscripts as sort of like fractions, and I notice the r's cancel out and it gives me this. That helps me remember how to add them together. Just think of a simple example of how this would work. If I had a river and I tried to swim with respect to the river, if me with respect to the river, if I try to swim straight across, but the river is actually moving in this direction, I know that I'll end up going in that direction. So it's kind of, that's the idea that we're working with. In my picture, I'm going to draw this. Here's my river, and I didn't really draw it very well, but this is the direction of the river flow. I should have drawn my river horizontally, but I'm not going to start over. This is the river with respect to the Earth. And then this is the direction that the canoe actually goes. And we said it was southeast because this is south and this is east. Now when you say southeast or northeast or any of those types of directions, it always means it's at a 45-degree angle. And so that's what that means. What we're trying to find is what is the velocity of the canoe with respect to the river. That's our unknown. Now, it's tempting to draw it as just straight down, like in the south direction, but let's be aware that we can't be sure of that, and we're going to actually do the calculations to figure that out. So, again, I'm going to write the velocity of the canoe with respect to the Earth is equal to the velocity of the canoe with respect to the river plus the velocity of the river with respect to the Earth. Now, the velocity of the canoe with respect to the Earth is 0.48 meters per second southeast, and the velocity of the river with respect to the Earth is 0.48 meters per second east, just to help me remember. Now what I'm going to do is I'm going to look at this expression in component form. So I'll do the x components first. And the idea is I'm going to solve for the x and y components of my unknown, which is this. And then I'll be able to find the magnitude using the Pythagorean theorem. So the x component of the velocity of the river with respect to the Earth, because the river was going east at 0.48. And then we're going to subtract the velocity of the canoe with respect to Earth, which is going to be 0.48 times the cosine 45 degrees. This is going to give me an answer of 0.14 meters per second. Since it's positive, it's going to be east. Then the velocity of the canoe with respect to the river in the y direction. So you'll see that I have a similar expression, but now I'm looking at my y components. The river with respect to the Earth doesn't have a y component, so that's 0. And then this is minus the velocity of the canoe with respect to the Earth, which is 0.48 times the sine of 45 degrees. So this is equal to minus 0.339 meters per second. And so what this is telling me in my picture, this was the velocity of the river with respect to the Earth, this was the canoe with respect to the Earth, and now it looks like my canoe with respect to the river has a little bit of a positive x component, but a negative y component, and that's what it looks like. But in terms of the magnitude, when I do the Pythagorean theorem, I get 0.367 meters per second, and that's it.